Say hi. Hi, my name is Paul. My name is Paul. No smiles? Come on, you have to smile to the camera. Not gonna smile? Okay. Well, I tried. Paul says it's because of this expensive thing in front of me. Yeah. Yeah, it is. Alright. Well, I'm going to hand him off because what I'm about to do is kind of complex here. We've received a number of questions over the years about rubber for model airplanes, and so today we're going to show off some kind of pricey tools that are part and parcel to the goings on of all of this. So if you're flying indoor, for example our Intruder A6 here, or some system of that nature, you are probably familiar with the need to strip rubber down to the proper thickness. Because rubber comes in basically four sizes. It comes in 1/16 inch wide, comes 3/32, 1/8, 3/16, and 1/4. That's 5 sizes, sorry. So the issue is, for indoor flying, that's too coarse of a margin, and for some planes, I mean, it's ridiculous. Like in a mini stick, you're going to be, in some cases, flying on 22,000th inch wide rubber. So you have to strip it down to thickness. So what I'm doing here is, this video has two purposes. One, to satisfy that question, the other to show specific operation of the specific system, because one of our viewers purchased one recently and wanted some instruction on how to use it. So I'm going to start with this unit right here. You will probably never see one of these up for sale. You may, if you pay really close attention. This is the Wayne Johnson rubber stripper, the Geauga stripper. Without question, this is the finest piece of indoor tooling ever made. So it comes with micrometer adjustments and so on. Has dual guide wheels for stabilizing the rubber as it goes through the cutting barrels. There are several different versions of these. Most of the parts are aluminum. Very nice system. Has custom designed stripping blades on it as well. And that's one of the first things. When you buy a rubber stripper, you need to be aware that these little rims here on those barrels, you don't really want to touch those that much because they are razor sharp. So the way this type of a system works, I'm feeding 1/8 inch rubber through here. Typically on this guide sheath, because this knob over here adjusts, it actually moves this piece in and out to set the receiving width of your rubber. Typically you're going to have that be a near interference fit. On this one you want it actually to be loose because you've got those stabilizing guides. So you can just feed the rubber in and you get this perfect cut. Let's snip this off back here, run it the rest of the way out, and there you go. So all you're going to do, all you really need to know is set this knob to set the feed width of the rubber. Follow the instructions from the manufacturer. Otherwise, what you want to do is just set it on any other rubber stripper than this one, so that the rubber just fits in there. It should move freely, should not have any resistance, but it should not have any side-to-side wiggle. And we'll talk more about that when we get to this one. And then you just set this knob, adjust it back and forth to get the width of your thinner piece that you want off of the rubber, or thicker, depending on what you're doing. Now, there is a right way and a wrong way to set the thickness of to verify the thickness of the rubber. And I'm going to show you the wrong way because I use the wrong way and it works for me. This is a dial thickness gauge. I believe Ray Harlan sells these, a newer version. This is an old one. This is a Mitu Toyo, which is a very sophisticated piece of equipment, quite old. This was originally owned by Tom Valley, famous for inventing the mini stick class. But what you can do to get your thickness is you're just lower that down on there. You get your thickness of the rubber in thousandths of an inch. So for example, this The rubber is almost always the same thickness in one direction, so 40 thousandths of an inch. That's the thin dimension that's stock. But anyway, this is what I've done is I've stripped off 30 thousandth rubber here. About the size for a low ceiling mini stick that you're running really hard. Just to, for verification, that shows that this rubber, which is 0.125 inches thick, it's currently reading 0.123, so that's kind of your compression amount, and that's why there's some issues with this. Also, the 40 thousandth inch dimension on a lot of rubber, that varies significantly more, and the old Tan 2 rubber is thicker. So the proper way is to measure the linear density of the rubber, so grams per inch, grams per meter, whatever units you want. I love grams per inch. It drives people nuts because you're mixing metric and English. But there's also another pitfall to that, which I'm about to mention to you. So we are assuming that this rubber is the same thickness all the way across after we cut it. And on a Johnson Geauga rubber stripper, that is usually true. Most rubber strippers, however, that is not the case. So I'm going to feed a piece of rubber through this one. And actually what I'm going to do, first of all, is I'm going to show you, we'll loosen this up. So this is the Oppegard rubber stripper. These are fairly common, and they're quite high dollar because it is a quality piece of equipment. So the way this one works is the upper barrel, you can see I'm able to turn this upper barrel without turning the lower one, so the upper barrel freewheels. You can feel a little bit of resistance. That resistance is the blade on the top rubbing against the one on the bottom. And there are set screws in here and whatnot that allow you to adjust that. But the bottom line is you want enough tension that when you restrain the one, you can feel it dragging on the other one. You don't want too much more than that. You can go a little more. And so the bottom line is this I can hold that blade still while I rub the other one. And you want to be real careful if you're having to sharpen these, just to do it right. But anyway, we've got this loose. Some of the really later Oppegards actually have a screw adjuster, just like on this unit. I think the Leesons do as well. But on this one, it's just on a slider. And so what you do is you have to feed this rubber in. And this is where it's a little challenging. So you have to feed it in, and you just drop this guard over to where it's touching the rubber. You put the little handle back across. Some people cut a clear plexiglass plate that sits over there that stabilizes the rubber, and I do recommend that because it tends to move around in there a little bit. But anyway, once it's set, you're going to want to put your thumb down and hold this thing down because it is going to rotate when you turn it in here. And so you can see this time I got it right because the rubber feeds smoothly. There's no dragging whatsoever. It just feeds smoothly, but it can't wiggle back and forth. Any drag on the rubber as it is feeding in will cause the rubber to stretch slightly, and you won't get consistent cutting results. And I'm not merely saying that it won't give you what you were predicting out here. I'm saying it will vary as you're cutting, and that makes the results literally worthless. So anyway, you feed this guy in here, and then you start to turn the wheel, and you do have to maintain a little bit of pressure back in here to get the rubber started feeding through. Going in there. There we go. Now it's feeding. And as you turn this, if you turn it nice and slow, you can actually feel feedback through that handle, a little bit of vibration. Then that vibration is the blades shearing that piece of rubber. Alright, so what I'm doing here is I'm going to cut just a short little piece. And you notice I haven't adjusted the thickness because I'm just doing this for an example, but I will show you that in a minute. Alright, so I've got this piece of rubber. I look at it so I see the shiny face on it. There's only one that's shiny. That's the face that you have cut. And looking at this, I can see a trapezoidal shape on the end. The other thing is I started cutting on this end, and you can't see it here on camera, but I can measure this. The end is measuring at point of contact where the needle starts to slow down in its movement, showing about 0.45 on the very end. But once I get further in here, is it showing? Getting about 0.43. So that's not 5, that's 3 or 4 thousandths of an inch difference. In some cases, actually, at the very end, where do you see it? Come on, you. Getting first contact around 0.48. So it tapers in and then it stabilizes. So this end out here is unusable. You have to snip that off. It's a different thickness from the rest of the rubber. But the other thing is, I'm seeing about 3 thousandths of an inch between the time where I can see that needle start slowing down to the point where it starts to bottom out. Actually, let me correct that. So I'm seeing first contact around 0.45, and then it keeps going down to, at one point I saw it drop down to 0.40. The bottom line is that there is this is trapezoidal, so there's a diagonalness to that cut. Where that really becomes a problem is now I've got this other strip of rubber which I might want to strip down to something else. So let's say I strip that off. There's going to be a second piece left. One of those is going to have double bevel on it, and you can't do anything with that. So you have to take that into account. But anyway, this little screw over here moves this platform back and forth. So I'm going to turn it this way. In theory, it gives you thousandths of an inch, but the issue is that's only for one thickness of rubber feeding in here, because since this does not have those little guide wheels, the rubber squishes a little bit as it comes through these barrels. And that means that our side adjustment actually varies how much you get per unit over here, depending on where you are on the edge of the rubber. So I've got this run way over here to the side. I'm going to explain what I've got going on here. Alright, so this thin piece that I cut off of here should be, looks like it's about 10,000. Nope, I was wrong. Showing 0.23. And this one's actually surprisingly not particularly, no, it's very diagonal. Never mind, one side's really thin and the other is quite a bit thicker. That's why it's showing 0.22. Because one side looks like it's only about 10,000. I wonder if I can just pinch it in here. About 0.18, and the thick side is almost 0.30. So that's the issue that you have. Now, here's what I wanted to explain to you. So I'm going to strip off the other side. So this is the side that I stripped off of, so I'm going to turn it over. So I'm at least getting the same thing out this other side. So what I'm doing is I'm feeding this back in here, and now I have to adjust my little feed gate thingamabobber. So I'm going to slide this over to where it's just in contact. Bring my thumb down here, clamp that nice and hard. Right, so I don't have any play in the end. I've got a little bit of play over here. It's feeding pretty firmly here. Well, it's not got any play in it. And back here doesn't matter as much. So, we'll feed this through. Alright, so the first thing I notice is the rubber, as it comes in here, it's tilting. And so that's going to make this significantly more diagonal than before. Now we're going to measure the thickness of this rubber, which is much more trapezoidal than before. So, and that's because it's narrow, so that's the issue you have. Yeah, so this time I'm getting a reading that basically the average thickness of this rubber is 0.27. So if you remember, previously it was 0.23. So that's the main thing that you need to know about this. As you vary that thickness of that rubber, you have to readjust. I believe that's everything that I wanted to cover about these. So if you have any questions, comments, put them in the comment section below. I hear there's one of these for sale on the indoor list on Facebook. So anyway, see y'all later.